Good morning, everyone. My name is Naikodi Shubham Shivaji. Today, I will present my internship project on microwave oven using embedded system. The goals of the project was automatic cooking, ensure automatic, accurate time control, and the system user friendly. I will explain microwave ovens, the cooking modes, embedded system design and of the project. The next one is the how to learn internship learning and outcomes. First one is introduction to C conditional statements, loops, and operators. During my internship, I gained strong fundamentals in C programming, starting with basic concept and processing to conditional statements, loop, or operator. I learned array and pointer, which helped my understanding memory handling, following function, and string. Along with programming, I study the basic embedded system and microcontroller, with focus on the PIC 16F877A. I work tools such as MATLAB, ID, XC8 compiler. I learn about various peripheral PIC 16F877A and perform interfacing components like LCD and keypads. To evaluate learning, multiple quizzes were conducted. I also attend the DISHA workshop. In DISHA workshop, which enhance my practical understanding embedded systems. That's are the in my internship. These are the content. First one is the what is micro oven? Micro oven. Second is requirement, embedded system, microcontroller and microprocessor. PIC simulation lab, LCD, matrix keypad, ISR, timer, and project implementation demo in my all contents in my PPT. So first one is the microcontroller, micro ovens. Introduction to microwave oven. Microwave oven provides multiple modes, each which with a different heating technique and control logic. In this project, we implemented four modes. First one is the grill mode. First mode is micro modes, grid mode, convection mode, start. In first, that's are the micro modes. First one is the microwave modes use only microwave radiation for cooking. It is mainly used for reheating foods, boiling liquids, and simple cooking. The heater or grill is off in the mode. The cooking time and power level enter keypads and status is displayed on the LCD. This is mode implemented using timer, keypads, and LCDs. Next one is the grill mode. Use heating implement. Grill mode use the heating implement to cook food is suitable for boiling, roasting, and description. In our project, the grill operation is simulated using timer and indicators. The cooking timers enter the keypads. These control the use to sandwich pizza. In our project, grill operation simulates using the timers and indicates. Next one is the convection mode. Combination of the microwave heating and hot air. That's are the in uniform cooking. It is suitable to baking, cook cakes, cooking, and bread. In embedded system, a timer interrupt control cooking duration and the LCD display selected modes and countdown. Next one is the start mode. In start mode, act, the start actual cooking process. This this mode is the actual process of the microwave oven. The start mode begins the actual process. It is execute the logic of the selected mode. Initialize the timer. Update the LCD. Start the operations. Ensure the correct sequence. Ensure that the prevent accidentally operation without selection. Next one is the embedded system definition. An embedded system is a specific purpose computer designed to perform a specific task. It includes hardware and software like microcontroller peripheral and the software part is usually firmware is the embedded C. Using microwave ovens and washing machine used in the automatic and medical system. Embedded system are used microwave ovens, while washing machines, car, medical device. In the next one is embedded system roles. Roles of the embedded system in microwave. In microwave embedded system, the control cooking time, modes reads, keypads, input and display info. The LCD use interrupt for the real control. It is un- it is it's also hand real time operation using the interrupt improve accuracy and the safety. This project automated automation and user defined operations. Next one is the microcontroller versus microprocessor. The microcontroller use CPU, RAM, ROM, and input-output ports on the single chip, ensure less power, and use the embedded system. In our project, we use to pick microcontroller 16F877A. Microcontroller microprocessor only use the CPU. It is use computer in high processing is needed. Next one is the PIC microcontroller. PIC microcontroller is an 8 bits RISC microcontroller. It has built-in timer, interrupt, and multiple input-output ports, making it ideal for embedded systems application in our project. It is controlled to LCD timers and overall modes logic. PIC SimLab. In PIC SimLab is used to simulate PIC microcontroller progress without hardware. It supports LCDs, keypads, LEDs, which during the debugging, learning, and the demonstration, it is used to simulation to the only software part in microcontroller. It is one tab is the software. Next one is CLCD. We we use to 16 into 2 character, 16 into 2 LCD display system in information. It shows the select mode, cooking time, and message interface, RS and EN control lines to improve the user interactions. Next one is a matrix keypad used for user interrupt. But the matrix keypad takes the user input for the selection and cooking time. It is arranged in row and column. Reduce require input output ports. Key scanning is implemented in the software. Next one is the ISR. ISR means in long form is the interrupt service routine. In in first one is executed when interrupt occurs. Second one used for timer overflow. Ensure accurate time control. Last one is improve real time performance. In ISR execute interrupt when the interrupt occurs, such as the is a timer overflow. In ensure previous cooking time and improve real time performance. Next one is the timer. Timer is used to count time, generate interrupt periodically. Times counts like the system generates interrupts at the fixed interval and control cooking duration. This is the LED countdown in a specific time. Use the countdown display. Initial for the real time systems. Times are essential for real system embedded systems. The next one is the software implementation. In software implementation, properly use an C language, embedded C in uh, percent compiler XC8 and modular approach LCD keypads and modes, easy maintenance and readable. The project is programmed using embedded C, compiler using XC8. We follow the modular approach with separate files and LCD keypads and modes logic. Make the code is easy and read maintenance. Next one is the project flow. First one is the power on system, display welcome screen. Next one is select code using keypad. Next one is the enter cooking time. Next one is the press one. Press one means press start. Time to start and cooking completes. Right. In the project flow, in system start when power on, welcome message is display on LCD. User selected mode. First one is the select mode. Enter cooking time and press start. The time start is selected mode executes and cooking complemented. Next one is the demo implementation. That are the MATLAB simulation in the project in desktop. It saves. First one is a microwave. In header files, clcd.h, matrix keypad.h, microwave oven.h, timer.h, and source file clcd.c, isr.c, main.c, matrix keypad.c, microwave oven.c, and timer.c. It is required to build the project successfully. The maintenance C. That's are the it is language is C language. In that the clcd.h, isr, matrix keypad, एक, 1 minute, ISR. In ISR, assigned character sec is equal to 0, unsigned character meaning is equal to 0. That's are the matrix keypad, micro microwave dot h, timer dot c, timer dot h, ISR. It is the in function in the PIC microcontroller 16 used in the in format. Next are the in the next one is the main.c. In main.c, microwave wanted to start the debugging in the clean and build. First one is the clean. Oh, clean is successful. Next one is the clean and build. Okay, you see that first one is some errors. Next one is solve errors and make build successfully. So next one is the pick microcontroller. In that the time first one is the load hex file reload. In file is save is the desktop. The first one is save the file in open. So display the screen powering on the microwave oven. In microwave oven, first one is the micro microwave. Second one is the grill mode. First one is micro mode. Second one is grill mode. Third one is convection mode. Or fourth is start. So I press first. In after in my PIC microcontroller, we used to PIC 16F877A in use. LCD is the types of EID 44780 16 into 4. So fan. Fan is when LCD start, cooking is start, fan is rotate, and buzzer. That's the buzzer. The buzzer is the when cooking is stop, buzzer is on. It is relay one. It is relay one. Pick microcontroller. That is the display one, display two, display three, display four. That is the one means micro mode, two means grill mode, three means convection mode, four means start, uh, five, six, other. I set only four, and first hash means enter, and star means clear. So first one is the micro mode. Micro select powering is equal to 9 900 watts. So we see the set time in minutes and seconds time. That's at the display. Blinking the second. It means second. First one is the timer set. We 30 seconds set. And next one is the enter. Hmm. That's the you are looking to fans are rotate. Is cooler. In specific type, cooking is ready. Uh, it can countdown is start. We are four means start a reason. For is press. Okay. Uh, five means first. We are stop. Next one is six. Six means stop. Okay. Next one is start. Okay. Countdown is slowly. Okay. Next mode is the It is a reset button. Next one is a reset. Powering on microwave oven. Next one is the grill mode. Press 2, set time, minutes and second. Time in second one is a blinking. That means a second. Star means clear. Hash means enter. We are second to 45 minutes. Second. We are enter. Next one is the enter. Countdown is start. Fan is on. In when the fan is off, the cooking is the ready. Buzzer is on. That's the display. In temperature 27.450. Countdown is start. Automatically fan is off. The wheel successfully up. Let's see time up. Okay, next one is the convection mode. Temperature in degree. Okay. So I will 25. This way 23 enter. So next is enter. That's are the three one is the convection mode. Press 3 45. Next one clear means all is clear. Okay. So 435 enter. Sheet plus time range is 16 seconds. Okay. Time is press. Preheating time remains 0 seconds. 16 seconds means 1 minute. That's are the convection mode. Oh. In our the PIC simulation lab, PIC microcontroller in this in that the first one is the micro mode, second is the grill mode, and convection mode. Okay. So next one is the activity. So advantages is this is the previous after the demo implementation. Next one is the advantages. User friendly interface, accurate time control, real time operations, cost effective solution, easy to modify and upgrade. The system is easy to operate, provide accurate times, is cost efficient. It can be modified easily. It can be modified easily. It is suitable for embedded applications and learning progress. So next one is the conclusion. In our whole project is built successfully. And which conclusion to be gained? How to study in the project? In the project, we successfully implementation microwave oven control system using an embedded system, real-time control achieved using timers and interrupt. Real-time control was achieved using timers and interrupt. This project enhanced our understanding embedded C PIC microcontroller peripherals and suitable for internship and academic demonstrations. Thank you for your text.